While equations tell us that two expressions have the same value, inequalities show that two expressions have different values. Just like in real life, our job with mathematical inequalities is to get to the root of things and determine what makes them unequal. Inequalities are defined by two expressions connected by an inequality sign. These signs can tell us the one value is simply greater than or less than the other, or it can show that one value is not only greater or less than the other, but that they could also be equal. Unlike equations, which usually have a fixed number of solutions, the solutions for inequalities show up as a range of numbers. For instance, if we think about values where x is less than 4, that could include anything as low as negative infinity up to but not including 4. The notation with the inequality sign is called set notation, but we also have a form of shorthand to note this. We call it interval notation. In interval notation, we list the lowest possible value, then the highest possible value. If there is a parenthesis next to the value, then the value itself is not included in the solution. We also do this with positive and negative infinity because they are not set values. If the number has a bracket next to it, then the value is included in the solution. So if we have x is less than 4, the interval notation is open parentheses, negative infinity, comma 4, close parentheses. If we change the inequality to be x is greater than or equal to 4, the interval notation would be open bracket 4, comma, positive infinity, close parentheses, because we start with 4 and can go as far as positive infinity. Now that we have the notation down, let's talk about solving inequalities. When we solve an inequality, we follow the same process as when we solve an equation. So, given an inequality, we will work backwards through the order of operations using the same operational equality properties as we do when we solve equations. Now you might be thinking, why are we using equality properties with inequalities? Well, while it is an inequality, we don't want to change the overall relationship between two expressions. So we still need to make sure that we are doing the same thing to both sides. For example, given 7x plus 5 is greater than 89, we will start by reversing the addition using the subtraction property of equality. 5 minus 5 equals 0, leaving 7x, and 89 minus 5 equals 84. Now we have 7x is greater than 84, so we'll undo the multiplication by 7 next, using the division property of equality. 7 divided by 7 equals 1, leaving just x, and 84 divided by 7 equals 12. So according to our calculations, x is greater than 12. The interval notation for this is open parentheses 12, comma, infinity, close parentheses. Meaning, anything greater than 12 up to infinity will make the inequality true. We could test this using a value greater than 12. Let's try x equals 15. Using the substitution property of equality, we will evaluate 7 times 15 plus 5 is greater than 89. 7 times 15 plus 5 equals 110, which is in fact greater than 89. Furthermore, we can graph the solution on a number line. We will start with an open circle at 12. This shows us that 12 is not included in the solution. Then we draw an arrow from 12 through all the values greater than 12. As long as the variable is on the left, this arrow will point in the same direction as the inequality arrow. The main difference with solving inequalities is that multiplying or dividing by a negative will change the direction of the inequality. Think about the statement, 3 is less than 4. If we multiply both sides by -1, we get -3 and -4, and we know that -3 is greater than -4, so the inequality sign had to flip. Now let's look at 3x divided by -2 is greater than or equal to 12. There is no addition or subtraction, so we will undo the division and multiplication. We will first undo the division by multiplying both sides by -2. This will divide with the -2 in the expression, leaving behind 3x, and negative 2 times 12 is 24. Because we multiplied by a negative number, we must swap the direction of the inequality. So now we have 3x is less than or equal to negative 24. Then we divide both sides by 3 to reverse the multiplication. 3 divided by 3 will leave x by itself, and negative 24 divided by 3 is a negative 8. Because we did not divide by the negative, the inequality sign stays the same, giving us a solution of x is less than or equal to negative 8. To check our solution, we will use a value less than negative 8. Let's try negative 10. 3 times negative 10 divided by negative 2 equals 15, which is greater than or equal to 12, as the original inequality states. This means our solution is in fact x is less than or equal to negative 8, or the interval, open parentheses, negative infinity, negative 8, close bracket. The graph of this inequality would look like this. The closed circle at negative 8 shows that the value negative 8 is included in the solution. Solving inequalities can help us to find the ranges where conditions are optimal for certain situations. It can also give us all the possibilities in situations where multiple options are available. In this video, we learned about solving inequalities as well as interval notation.